Yo, what's good? Hopefully you're doing well. This is the third kind of video of me just doing questions, kind of just to help me review material and just force myself to study because I know for a fact I hold myself accountable to posting videos daily. So today we're just going to continue on acids and bases. Honestly, we're just in just continuing on with kind of the similar stuff. And it's just like the unit of chemical equilibrium. So yeah, I just wanted to kind of if I'm able to if I'm just wanted to challenge myself to try and explain stuff. I tutor math mostly, so I just kind of wanted to expand it to different subject areas, and that's kind of what the main focus of this is. So today we'll just be doing two questions. I think this one will take a fair bit of time because when I did this, when I was practicing, it took me quite a bit of time. So I guess we'll just get started with this. So this question is asking there's three parts to the question. First, it's asking the concentration of each species that is present. Next, what is the pH of the solution, and what is the pH after adding 0.005 moles of HCl to the flask. So let's just start with part A. I look, you need to go to sleep soon as well. So yeah. So NaOH is a strong base. So NaOH, it'll dissociate into one OH minus and then two Na plus ions. So this means that there will be an equal amount of moles for each one. So there will be 0.0, but why is it glitchy? 0.05 moles of OH and 0.05 moles of Na plus. Na plus won't really react in this reaction with the acid. So I guess we could just call this a kind of spectator ion. Because it's not really involved in the reactions that we're kind of interested in. So we're just mainly focused on the OH minus. So we know that there's 0.05 moles of OH minus or hydroxide ion. Next, because this is a strong base, and also we got, I'm pretty sure that's a strong acid. I need to memorize the strong acid still, but the hydroxide ions will react completely with the hypochlorous acid or the HClO. So what will happen is that a weak conjugate base, ClO minus, will be formed from this kind of reaction. So quickly just drawing the equation out just to make more sense of it. We have HClO plus OH minus with the equilibrium arrows to ClO minus plus H2O liquid. So we could just start with the ice table. So ice tables are definitely a common theme here. I mean, I guess it's equilibrium stuff, so it makes just sense, but I don't even know, bro. I just don't really enjoy school. I guess maybe this makes it a bit more fun because I could just ramble on about stuff and things like that, but I don't really know. But anyways, so we get we know that there's 0.13 moles of hypochlorous acid, so 0.130. We don't really need to write the third zero, or yeah, just 0.13. And then we have 0.05 moles of hydroxide ion, and then we start with 0 moles of HClO and 0 moles of H2O. We could just ignore those two. And then because the limiting reagent is hydroxide ions, this will be minus 0.05, minus 0.05. This will be plus 0.05, and we don't really have to worry about this. So what we're left with here is 0.080, 0.05. So that's what we're left with at equilibrium. So with that, that is the kind of amount of moles of HClO that we'll have in this kind of solution. Now the question is asking for the concentration of each species. So to find HClO, that would simply just be 0.080 moles over, because it's 500 mils, so this would be 0.5 liters. This would just end up being 0.16 moles per liter. And then for the ClO minus, this would just be 0.05 moles divided by 0.5 liters, which is just equal to 0.10 m, or moles per liter. Doesn't really matter. So that's HClO. This is ClO. What else do we need to find? We need to find the H3O concentration, like the hydronium ions. So that's what we'll do now. This is honestly way more complicated than I feel like it should, but I don't really have any say in that. let me just open up my formula sheet. I should have downloaded that or opened that before. So to find the concentration of hydronium ions, because this is a buffered solution, I think, again, like disclosure, I'm still learning this as well, so maybe don't take my word for everything. But I'm pretty sure the reason, there's like this equation that we use, right? It's called the HH equation, like the Andrew Huberman. I don't know. It's not. It's like some random name or something, and we could use that as long as there's a buffer to find out what the pH is, or what what was I looking for? But I can't find this equation. What like the pH is, or like stuff like that, right? That's just how I have it in my mind. So that equation or that formula is pH is equal to pKa plus log and then base over acid. So from what I know is that in this thing here, we could have like, we could have moles, we could have concentration, stuff like that. It doesn't really matter as long as the ratio is constant between the two. I'm not constant, I mean like the same units. So in order to find out what the pH is and to find out the H3O concentration, we need to find the pH first. So pKa of this here is just, pKa is equal to, wait, that's one more thing I should probably mention. pKa, I was also confused about this, is equal to negative log Ka. So we got to find the Ka value. The Ka value of HClO, that is, bro, I got to find my data sheet, bro. That is 2.95 times 10 to the negative 8. So if you just substitute that in really quick, we get negative log 2.95 times 10 to the negative 8. I'm not sure if you can hear my parents talking. There's like some beef in our family group. Not family, not in family, but it's just like friends and stuff like that. Complicated stuff. Anyways, once we solve all of this, we should get a value of 7.33. That's where our pH is. We need to find the H3O concentration. So to find the H3O concentration, that is just equal to 10 to the negative pH, so negative 7.33. And then if you set that equal to, you get a value of 4.7 times 10 to the negative 8 moles. And that is our concentration of H3O. So overall, the only things that we're concerned about is H3O, NaOH. I guess you got to do the divided by 0.5 liters, and then you'll get the concentration of OH minus. But yeah, you got 0.16 moles per liter of HClO, 0.10 moles of ClO minus, and then it's 4.7 times 10 to the negative 8 moles per liter of H3O. So that is part A. Honestly, that was way more complicated than I thought it would be. Part B, this should be relatively more simple, perhaps. Oh wait, we found the pH. It was right here. So we got the answer right there. So 7.33. Nice, that's easy. Okay, now part C. Okay, so upon further thinking, this is actually much more easier than I thought it would be. So the question is saying that, let me just move this down here, just so it's easier. So the question is asking, what is the pH after adding 0.0050 moles of HCl to the flask? So this is a strong acid, HCl. I know that for sure. I just remember that. So we're adding this to a buffer solution we have here, because clearly in the solution we have both ClO minus and HClO present. So we got a buffer solution with that. So when we add HCl, that will react with both the acid portion of it and the base portion of the buffer, kind of, because with the buffer we have some acid, we have some base, things like that. Pretty simple. Maybe I'm just oversimplifying it, but anyways, we're gonna use like the same HH equation. I probably should figure out what it's actually called, but pH is equal to pKa plus log of the base over the acid. So I'll just write this out for simplicity: ClO minus over HClO concentration. So we know from the previous part that the pKa is just negative log 2.95 times 10 to the negative 8 plus log of the concentration of ClO minus. So that's kind of what the first portion of the question helped with, is just finding out what that is. But now with the ClO minus, we have to subtract the amount of HCl we're adding, because this is the base, right? So the base will react with the acid, and that will reduce the concentration of base, because we're adding acid, so we're reducing the concentration of base because they're reacting together. So we got 0.0050. Wait, no, wrong. We got 0.050 minus 0.0050 all over 0.080 plus 0.0050. And once we get all that, we should get a value of 7.25. And that would just be the pH in the end. So I hope that kind of last part made sense. So we're adding 0.0050 moles of HCl. HCl is an acid, so the acid will react with the base portion of the buffer. So we got a concentration of 0.050 for like the base from this portion here, I believe. No, this portion here, 0.050, because that's the amount of base that we have in our equilibrium solution, the buffer solution. That's the base, and then for the acid is HClO, and that's 0.080. So the acid is 0.080 plus 0.0050 because that's HCl. HCl is an acid, so we're adding acid. And then for the base, we have to subtract it because it's reacting with each other, so that's why that's why we do that stuff, so that's just the answer for this question, 7.25. Okay, so here's the second question. Honestly, I think this one will be much more simple, and I'll just go over it quickly because I also low-key need to go to sleep. So what we have here is that we have NaOH mixing with a weak acid. So quickly, we have because NaOH is a strong base because it's group 1, like sodium is group 1, and then we have a weak acid. So when these combine, what we're going to get is a solution with a weak conjugate base. This comes from the weak acid. The strong base is just neutral in solution after mixing, so it doesn't really do anything. Again, disclaimer, I'm just explaining things how I understand it. Maybe I might be wrong, but this is just how I learned, and I might learn how to do it properly later. So that's just what I know for now. So what we need to find is the ending pH. And the way we'll find that ending pH is just by looking at the kind of equilibrium concentrations of everything, and then using the HH equation. Again, I don't really remember what the name is, like Hasselbalch or something. I really don't know, but I really feel like that's kind of irrelevant. But anyways, the first thing I would do for me, like just what makes sense for me, is just to kind of write out the equation. So we have OH because that is the base, plus we have a weak acid, we don't know what it is, so we can just call that HA, equilibrium A minus plus H2O liquid. Then we could just make the ice table. So yeah, we're making a lot of ice tables. I think I already said this, but it's just really annoying, but that's just how it is. Okay, anyways, so to fill out this kind of ice table, we need to find the moles per liter of each thing, so we'll just do that quickly. So for NaOH, we have 0.150 moles per liter, and then we have 500 mils, so that's just equal to 0.500 liters over 1. Liters cancel out, and we're going to be left with 0.0750 moles. So now, this is what I'm a bit confused about, because if this is 0.150 moles per liter, then the liters are just canceling out, so we don't really have moles per liter. But I guess we could just say it in like a liter, so I think we'll just continue on with this. That's just how I remember I did this question. 0.200 moles, so this is for OH minus. Then we got like the HA. So 0.200 moles per liter multiplied by 0.585 this time. Cancel out liters, what we're going to get is 0.117 moles. So now we can just fill this out. In a way, maybe we should just keep this units constant, so this would be moles. So here we got 0.0750 moles of OH minus. We got 0.117 moles of HA. We start with 0 moles of A minus, which would be the conjugate base here. And then we don't really have to concern ourselves with H2O. Next, what are we going to kind of react with? Well, this reaction is going to go to completion because we have a strong base, and the limiting reagent is clearly OH minus because we have less moles of hydroxide ions. So we could just subtract the amount there, 0.0750. I don't know why I wrote moles again. Then this would be plus 0.0750, and this would just be cancelled out. So here we're going to be left with 0 moles of hydroxide ions. Here we're going to have 0.0420 moles of HA, and then we're going to have 0.0750. So that's going to be our equilibrium concentrations, or moles. So now we could just kind of quickly input this into our HH equation. Again, I don't know how many times I said that. I really don't know the name of the equation. So here we have pH is equal to pKa plus log concentration of base over concentration of acid, and then we can just substitute in the values. So pKa, we know from the question that the Ka is 6.16 times 10 to the negative 5, but pKa is equal to negative log Ka. So we could just fill that in. So we got negative log of the Ka value, which was 6.16 times 10 to the negative 5. And then we got plus log just the concentration. So what is the concentration of the base? That would just be 0.0750, which we got up here. And then we have over acid, which is 0.0420. And then once we input all that, we should get an answer of 4.46. And that is the pH of the solution. And that's the answer to our question. So that's going to be all for today. Hope you enjoyed, or hope you learned something. And if you have any recommendations on what I should cover, just let me know, and I'll try my best to get to it, even though I'm learning as I go, honestly. With this, it's just kind of re-solidifying my my understanding of these topics, and that's honestly why I like to do it. So yeah, I'll see you tomorrow for the next video.